Hello everyone, class 12th topic is reaction of 1 degree, 2 degree, 3 degree alcohol with copper at 573 Kelvin temperature. Its mechanism we will understand. Mechanism is not included in the syllabus of 12th class, only the reaction is there. Let's understand first what are the products. For 12th class, simply we can learn 1 degree alcohol when will react with copper at 573 Kelvin will create aldehyde with the loss of hydrogen gas. 2 degree alcohol with similar condition will create ketone with the loss of hydrogen gas. 3 degree alcohol with this will create alkene with the loss of water molecules. Means in 1 degree and 2 degree dehydrogenation is happening. Dehydrogenation means loss of hydrogen gas. And in 3 degree dehydration is happening, means loss of water molecules. So up to 12th level, you just need to learn these reactions. For example, I am using 2 degree alcohol. This is 2 degree alcohol. Now how to do its dehydrogenation? This hydrogen and this hydrogen means hydrogen of oxygen and hydrogen of this carbon, alpha carbon. This you have to eliminate, and between carbon and oxygen you need to make a bond. Release of hydrogen gas. Similarly, for 1 degree alcohol, if you are using, suppose I am making this as a 1 degree. Now this is 1 degree. So same condition, this hydrogen, just remove them as a hydrogen gas. Now this will generate. This you can check, aldehyde it is. And for 3 degree alcohol, you need to do dehydration of it. And how to do dehydration in previous videos we have covered. For dehydration, this carbon, this alpha carbon do not have hydrogen, so H will not come from here. Beta carbons you will check. Any beta hydrogen and this OH group just released out and H2O will release out, and between these carbons, the carbon which is losing H and the carbon which is losing OH will make a bond. How to perform dehydration reactions we have already discussed. If from all beta carbons we are getting same alkene, so no problem. But if beta carbons are different, so major alkene will be most stable alkene. Please check that one. Up to 12th level, this we have. Now let's understand its mechanism. How that reaction is happening. First, 1 degree alcohol. That mechanism I am going to tell you now. Very easy mechanism, not so tricky. Copper is providing rough surface area. Copper is working as a catalyst here. Rough surface. On this rough surface, this mechanism I am writing for 1 degree alcohol. Its general formula I am going to use this one. Now on this rough surface, this alcoholic molecule will be adsorbed. Adsorbed means it will remain on the surface. Like this. When it will be adsorbed on the surface and in hot condition, its weak bonds breakage will start. Look, as you know, between oxygen and hydrogen, weak bond is available. Why? Because oxygen is more electronegative than hydrogen, so electrons are mostly toward oxygen side, and whenever electrons are moving to one side in covalent bond, the bonds are getting weaker. Means this bond is weak. Here we have positive charge on hydrogen and here we have negative charge on hydrogen. Firstly, this bond will break on the surface of the copper. How it will break? Both electrons will shift toward oxygen side and from here we will have a release of H positive ions. So next diagram I am drawing. Everything will happen on the surface of copper. The molecule will remains adsorbed on it. These particles will generate alkoxy intermediate. This is alkoxide intermediate because oxygen is carrying a negative charge and this is alkyl part. Alkoxide intermediate it is. Now here oxygen will become unstable because it get extra pair with -1 charge. So how it can stabilize itself? It will tend to make bond with carbon by shifting these electrons here. Carbon-hydrogen bonds are also weak because carbon is more electronegative than hydrogen. So these bonds are also weak. Carbon-carbon bonds are strong. So what will happen when these electrons will come here? These electrons means between carbon and hydrogen, the electrons will get shifted toward hydrogen because these electrons will push these electrons toward hydrogen, due to which there is a release of hydride. Next diagram I am going to draw here. Between carbon and oxygen, double bond will generate, aldehyde will generate over there, and what will release out? H positive was already there. This hydrogen will get extra electron from carbon, will become hydride. This is hydride and this is hydronium. Negative positive will combine to release out as a hydrogen gas. In this form, aldehyde will leave the surface and hydrogen gas will leave the surface. So on the copper surface, aldehyde and hydrogen gas will be generated in this fashion by 1 degree alcohol. Now if we talk about 2 degree alcohol, same mechanism. At the place of this hydrogen, I just need to put R there to make it 2 degree alcohol. R here, R here. You can check what is released out. Ketone is released out. Same mechanism. Hydrogen gas will be generated with 2 degree alcohol. Now with 3 degree alcohol, how that mechanism is happening, please check. This is the general formula of 3 degree alcohol. It is adsorbed on the surface of copper, heated copper with a temperature of 573 Kelvin. Now in 3 degree alcohol, please note down, this carbon oxygen bond is very weak, this bond. In 3 degree alcohol, this carbon oxygen bond is very weak. Reason? Because 3 alkyl groups are there and we know what is the nature of alkyl group. They are electron donating groups. Plus I effect. As you know, oxygen is more electronegative than carbon. Already it is pulling electrons toward itself, due to which the bond was getting weaker. And this effect is enhanced from plus I effect of these 3 R's. When these electrons will come toward this carbon, these electrons will get further pushed toward oxygen. Or in simple language, you can say these 3 pairs are making these electrons more attracted toward oxygen, due to which there is a more movement of electrons in this bond. That's why the bond will become very weak. So in this case, this bond will break first. Second reason, after breakage of this bond, you can check 3-degree carbocation will generate, which is more stable carbocation as we compare to 1-degree, 2-degree and methyl carbocations. So this factor is also making this bond to be broken. In this fashion, bond will break, both electrons will shift toward oxygen because carbon is less electronegative, and these electrons which are coming from our side are pushing these electrons toward oxygen. So what will happen? Here, okay, at the place of R, okay, R I am writing, R will have hydrogen, one carbon I can write here, this one. This carbon will become carbocation, and here we have a release of OH negative particle because this oxygen will get extra electron. Now this carbocation, we know how it will be stabilized. It will be stabilized from its alpha carbon. How? These neighboring carbons will break bond from their hydrogens and will shift electrons here. Between the vacant orbital and this pair of electron, double bond will generate, and from here what will release out? H positive without electron, because one electron of hydrogen is now with this carbon and which is shifting toward the positive carbon, due to which the next condition generated will be this. The vacant orbital of this carbon will be fully filled now, positive charge will finish, stable it is now, double bond will generate. So which product it is? Alkene it is. H positive is released out, OH negative is released out, they will combine to create H2O. In this fashion, 3-degree alcohol is showing dehydration on the surface of copper. That's it. This is the end of the video. Now in next video, we will understand how we can distinguish between 1-degree, 2-degree and 3-degree alcohol by different chemical tests. Thank you very much.